Hello everyone. In this session we are going to discuss about CPU scheduling algorithms. So what is the overview of this presentation? We are going to discuss in detail about CPU scheduling algorithm. So CPU scheduling algorithm, so it is the process of deciding which process will own the CPU to use while another process is suspended. So whenever the process is under execution, no other process can get inside or get into the another state. So that is what the process is suspended. Next, the main function of the CPU scheduling is to ensure that whenever the CPU remains idle, so CPU remains idle, the OS has at least selected one of the processes available in the ready to use the line. So here the CPU scheduling is under one process is under idle state. So OS has at least one of the processes available in the ready to use line. So only one process is ready for the to use that line. That is how this going to function. In multi-programming, if the long-term scheduler selects multiple input-output binding processes. So input-output binding processes nothing but whatever the input-output operations can be performed together. Then the most of the time the CPU remains as idle. So most of the time will be remains as idle. Next, the function of an effective program is to improve resource utilization. So the function of the effective program is nothing but to improve its resource utilization. Next, if the most operating systems change their status from performance, so if they want to change their status for their performance, then then there may be always a chance of failure in the system. So here if the operating system change their status, so if they want to change their status, it may get some failure of the system. That is how the systems attacked or how the systems gets failured. This is what about system failure. Next, so in order to minimize this excess, the OS needs to schedule tasks. So multiple tasks cannot be performed at a time. So for each task, we need to schedule some different tasks. So in order to make full use of the CPU and avoid the possibility of a deadlock. Deadlock we are going to discuss about in the next third unit, which is nothing but about deadlocks. So here OS needs to schedule the task in order to make the fulfill the use of the CPU. So how we are going to full use of the CPU to minimize the excess. That is what about CPU scheduling. Next, what are the different terminologies used in CPU scheduling algorithms? Nothing but arrival time, completion time, burst time, turnaround time and waiting time. These are the terminologies we are going to see in CPU scheduling algorithms. First, arrival time. What is arrival time? The time in which the process arrives in the ready queue. That is what when the process is arrived in ready queue. So let us draw our ready queue. So this is ready queue. So first arrival time. So P1 is under 0. So our ready queue starts from 0. P1 is under ready queue. The time at which the process arrives in the ready queue. This is what? Arrival time. Next, completion time. Time at which process completes its execution. So this is arrival time. This is burst time. And next we are going to see about completion time. We are having some n number of processes. For this we are having some burst time and we P1 with the burst time 3. So P1 completes its execution at 3. So here the completion time is 3. That is what? The time in which the process completes its execution is known as completion time. Next, what is the burst time? The burst time required by a process for CPU execution. So here the burst time is 3. It contains only 3. The burst time of P1 is 3. Next, turnaround time. The time difference between the completion time and arrival time. So CT minus AT is known as turnaround time. Next, what is waiting time? The time difference between turnaround time and burst time. Nothing but waiting time equals to TAT minus BT. Nothing but turnaround time minus burst time. These are the terminologies we are going to see in the problems. Next, the different types of CPU scheduling algorithms are mainly of two types. What are they? Preemptive scheduling and non-preemptive scheduling. In this preemptive scheduling, it is used when a process switches from running state to ready state or for waiting state to ready state. So what is preemptive scheduling? When a process switches running to ready or from waiting to ready, that is what preemptive scheduling. Whereas non-preemptive scheduling is used when a process terminates, means the process terminated, or when a process switches from running state to waiting state. So here in preemptive we are using from waiting to ready, whereas in non-preemptive we are taking from running to waiting. That is the difference between preemptive and non-preemptive. Let us see the CPU scheduling algorithms, how they are going to divide. So CPU scheduling algorithm is divided into two types, preemptive and non-preemptive. What are the preemptive scheduling algorithms? Are nothing but priority scheduling, longest remaining job first, next shortest remaining job first, and round robin. These all are nothing but preemptive modes. Whereas non-preemptive mode, shortest job first, longest job first, first come first serve, and highest response ratio next. So in this we are going to discuss first about first come first serve scheduling algorithm. So let us see our first come first serve scheduling algorithm. So in this first come first serve scheduling algorithm, it is considered to be the simplest of all the operating system with their scheduling algorithms. It is the simple and first algorithm used in CPU scheduling algorithm. That is what first come first serve. In this first come first serve scheduling algorithm states that the process that requests the CPU first is allocated, that comes for first. So the CPU which is allocated first, that is implemented by using FIFO queue. Queue is nothing but first in first out. So what are the characteristics of FCFS? FCFS supports non-preemptive and preemptive CPU scheduling algorithms. So it consists of both, or it supports both preemptive and non-preemptive of CPU scheduling algorithms. Next, tasks are always executed on first come first serve concept. Why? Because we are using first come first serve, so that the task will be completed only on the basis of first come first serve. Next, FCFS is easy to implement and use. It is very easy, and how we are going to solve, let us see. Next, this algorithm is not much efficient in performance. It is not much efficient in performance, and the time wait will be high. So the waiting of the time will be high. That is what one of the characteristics of FCFS. Next, what are the advantages of FCFS? It is easy to implement and it is first come first serve method. What are the disadvantages of this FCFS? FCFS suffers from convey effect, means how they are going to convey their effect, means how the processor are waiting. Let us see with the diagram, with the example problem. The average waiting time is much higher than the other algorithms. So the average of this waiting time is higher than other algorithms. Next, FCFS is very simple and easy to implement, and it is very simple and easy implement, and hence not much efficient also. So let us see our first problem on FCFS. The example problem, suppose we have a set of 5 processes whose arrival time and burst time are given. We have to schedule the process using FCFS and calculate the average of waiting time. So these are the 5 processes given and burst time and next arrival time. So let us start our problem. So first we need to take the all 5 processes. So process, what are the 5 processes? P1, P2, P3, P4, P5. Next we need to take arrival time, nothing but 80. What is the 80 here? 0, 2, 3, 4, 6. So 0, 2, 3, 4, 6. What is the burst time? 6, 2, 8, 3, 4. 6, 2, 8, 3, 4. So next we need to calculate the completion time, turnaround time and waiting time. So this is the problem we need to solve. So let us start our Gantt chart. Gantt chart is nothing but the processes which are under execution is known as Gantt chart. So first in this Gantt chart, the first the arrival time starts with 0. So at the time arrival 0, which process is under execution? So P1 is under execution. So take P1. So with the burst time how much? 6. So 6. So now we need to take from 0 to 6 which all are processor under ready queue. So let us see. So the processors which are ready for waiting for this CPU. P1 completed. Next P2 is ready queue, P3, then P4, then P5. So P1 is completed. Next which process? This is first come first serve. So the process which comes first will be executed first. So P2. So with the burst time 2. So we need to add 6 plus 2. How much? 8. Next, which process is ready for the execution? P3. With the burst time 8. So we need to add 8 plus 8 is 16. Next, which process is ready? P4. With the burst time 3. 16 plus 3 how much? 19. Next, what is left? P5. With the burst time 4. 19 plus 4, 23. So this is what our Gantt chart. So now the process completes P1 with the execution time is 6. So completion time of P1 is 6. Next P2 is 8. Next P3 is 16. Next P4 is 19. Next P5 is 23. So this is what the completion time of each process. Next turnaround time. What is the turnaround time formula? CT minus AT. So what is CT here? Completion time minus arrival time. 6 minus 0 is how much? 6. 8 minus 2? 6. 16 minus 3? 13. 19 minus 4? 15. Next 23 minus 6? 17. So this is what turnaround time. Next, what is the waiting time formula? TAT minus BT. So turnaround time minus burst time. 6 minus 6 is 0. 6 minus 2 is 4. 13 minus 8 is 5. Next 15 minus 3 is 12. 17 minus 4 is 13. This is what about first come first serve. In this they are told to find the average of waiting time. What is the time average waiting time? We need to add the waiting time. So total waiting time by number of processes. So total waiting time by how many processes are there? 5. How much? So 34 by 5. 34 by 5 is nothing but 5 ones are 5, 6 are 30. So 6%. So average of waiting time is 6%. So this is what about first come first serve scheduling algorithm. If you have any doubts, you can comment in comment box. So what we have discussed in this CPU scheduling algorithms? What are the 4 different types? FCFS and terminologies and preemptive method and non-preemptive methods. So in this session we have discussed about CPU scheduling algorithms and problem on first come first serve. What are the terminologies we have seen, and preemptive and non-preemptive scheduling algorithms. So thank you.